everyone. Welcome to this new series. I'm very excited about it. This new series, it'll be 12 episodes on just RPC, Remote Procedure Call, which is the foundational layer of everything Web3. I've found that a lot of developers don't actually understand RPC at a core, just through evidence such as browsing through dApps, even very well-known dApps, and then figuring out that the RPC is definitely not optimized, which leads to a lot of issues. It leads to sluggish apps, and it leads to higher than necessary costs for the dApps as well for your project. So by understanding RPC, it's extremely important because of the foundational layer in any dApp, and by optimizing it or using it the right way, so to speak, we can actually both save money and bandwidth and make the dApp go a lot quicker and be a lot more responsive. But it appears to me the big problem in Web3, or definitely one of the biggest ones, is that developers don't really understand RPC. This series will do away with that. We are going to understand everything about RPC. All right. So before we get to the bottom of it, let's just take a look a little bit, just so we can kind of focus in on what RPC is. Let's take a look at a code snippet here. So in this code snippet I'm showing here, okay, this is sort of like a very standard call to get a balance. But just in case you're a junior developer or new to Web3, let's just cover a little bit more what this is in plain English, right? So VM here, okay, as you see right here, it is just a JavaScript library, all right. And what does it do? It talks to Ethereum. Mainnet here just means you're talking to the Ethereum mainnet network, okay. And the client here is your essentially it's your open connection to it. So it's like that's the thing that's you can think of like a phone line, right? So the client is like your phone line, and you can ask questions through this phone, okay, to the mainnet, to the Ethereum mainnet. Client at get balance of some address, some Ethereum address here, does exactly what it sounds like. It takes in the address that you want to get the balance of, and then it's like asking what's the balance of this wallet, and then a number comes back, and that number is measured in Wei, which is the smallest unit of ETH, and just similar to how cents is the smallest unit of dollars. And that's the whole program right now, and then imagine you have some other application code, and of course also some code after this. You're going to need to do something with the balance, or else this would be a quite useless call. But basically it's just these lines, and all we're doing is just asking the Ethereum network a question and getting an answer. That's all this shows right now. Okay. The thing is that something genuinely strange happens right here in this call, in the get balance call. Okay. The computer that's actually doing the work, meaning the computer that's actually getting the balance, all right, it is not your laptop. Okay. It's a server that you've never touched. You're probably sitting on another continent. It's owned by a company you may have never spoken to. And somehow your code still calls this function on that machine, just like it's a local function, right? This looks like it's a local function. Just get balance, sure, go and get the balance, right? It doesn't feel like it has to do all that network stuff we just talked about, meaning communicating with a server far away. But in fact, that's what it does. So this is, this kind of hides and abstracts away all that complexity. And it just feels like you're calling a local function on your local computer, just like a, math.max of A and B, right? That would, A and B would be stored in the registers, and you would call it locally, and it can figure everything out on its own. Not in this case. It is calling a server far away. All right. So that's, it's crazy that everything is abstracted so much away that the single function here hides an absolute sea of complexity. Okay, that's extremely important to know as a developer. All right, but it's kind of beautiful in a sense that it's all abstracted that much away. We'll understand why. So this is going to be the first episode of a deep technical series on a piece of internet infrastructure that every developer uses every day. And we'll see it extends way beyond blockchain. We're going to see that in a second. But by the end of the series, you're going to really have built an RPC from scratch. So you really, really understand. I really want you to really know what's going on, not just explain it. Just you're going to be building it from scratch. And so you're going to understand exactly how it works under the hood. All right. And what that does, what I really hope that does for you is like you're not going to be that rare developer in the room who actually understands this layer code. And that's really going to set you apart because, again, we've done a lot of research on this. Not a lot of developers understand RPC at the end of the day. We just sort of just kind of hand off the problem to these companies, and they like that because it means they can charge you more money, to be kind of blunt about it. But the user doesn't really like it because it means your dApp is more sluggish. It's slower than it should be. It takes longer to load. Doesn't feel like what we're used to from Web 2. All right. And it just doesn't because we don't know how to do it right. So that's the idea. All right. Now, back to this idea of local functions. Okay, so not these remote functions. We'll define this a lot more precise in a moment. But these local functions, something that just runs locally on your computer, like, again, max of A and B, like we talked about. When your CPU gets to this function, it just executes those instructions, right? So the arguments are sitting in the registers. The function is just bytes in memory, right? A few inches from the CPU. It's very local. It's on your machine. The answer comes back in nanoseconds, basically, right? And that's a function call. Max of A and B is a function call. But if we look at this one again, so await client get balance. The actual logic that knows your balance does not exist on your machine, okay? Like the actual function behind that. It lives on some Ethereum node, okay? And this node, it could be in Frankfurt, it could be in Virginia, it could be in Sao Paulo. I don't know, could be anywhere. The point is it has access to the blockchain. Your laptop does not, in general. Your laptop does not. Like in 99% of cases, if it does, then that's a separate conversation. But when you write these dApps, you do not have access to that in that sense. So the point is, when your CPU hits this line, it can't just execute it. There is no get balance for it to jump to. It doesn't have the function locally. It doesn't have the Ethereum node locally. Okay, that's the point. So the address you want the balance of, right? The rules of Ethereum, the actual state of the chain, all these things, none of that is here. But yet, somehow a number comes back, right? You call this, you get a balance, you put the balance on the UI, on the front end for the user to see the balance. And, it's as if you called a local function. So the as if, right? The as if you call the local function instead of remote is doing enormous work. All right. And we'll really learn. That's why we have 12 episodes and not, I'm not finishing now saying that's all it is. We have 12 episodes of very deep dive into this. It's doing a ton of work, fantastic amount of work. It's really an ocean of physics and engineering that sits behind it. That's not an exaggeration. So you can say, in a sense, if you want to go this far, this line of code is a little bit of a lie. All right. It's useful. It's beautiful. It's a productive lie, but it's a lie. All right. So it pretends locality, you can say. It pretends, hey, I'm just a local function. When the CPU gets here, sure, let's go into this function, let's execute it, get the variables, and return. But it is not local. All right. Now, the category of lie, if you will, that it belongs to is what this entire series is about. All right. So this so-called lie, it has a name, and it's called remote procedure call. Ta-da! It's called RPC. That's what this is. That's what this line is. Now, let's go here. Remote procedure call is a technique. Okay, so it's not a protocol. It's not a library. It's not a product. Okay, but it's a technique of making a function call on another machine feel like a function call on your machine, just like we talked about. So the goal of RPC is really just hiding the network, fully hiding the network, abstracting everything away. So really, to kind of generalize it more, anything that takes a function call, ships it across a network, just like here from a client, right? Takes a function call, ships it across a network, brings back the answer. That's what this line does. So it went on the server, did some computations, brought the answer back. That's what this happens. So it goes back to the client. That's RPC. That's what it is. Easy as that. So let's go up here again. So we write client.get balance of address. This is what we call the called site. So the specific location, in the code where this function was called, that's called site. Now, code inside the client library, which is VM in this case, takes this call and it packages it up. Okay, so, just to kind of standardize it, to be able to send across the network in certain bytes. So there's certain standards, of course, that networks use to send messages to each other. So it packages everything up, such as like what function are you trying to call on the Ethereum node, and what argument are you calling it with, and so on. And maybe we attach an ID and all these kind of stuff to that. All right. The package is then shipped over the network. That's what happens here in this arrow. So the client just did all this work, the VM client in this case, shipped it across the network to the server. Shipping it across the network just means, some bytes are leaving our client and they go to the server. And on the server, it then reads those bytes, right? And it understands it, what it is. Then that's what the unpacking is about. So it deserializes it. So the client serialized it, the function call, create a byte from that, send it across the network. Server now deserializes that into, hey, what are you trying to do? What were you telling me to do? What are you telling me to run? All right. So it figures that out. And then it runs the actual function that queries the blockchain state. All right. So it gets a result, in other words, and then it packages that up and then it ships that back along this arrow. So it goes back to the client. Now we know the result. We know the balance in this case. And technically speaking, this await, as we like to say, then resolves, meaning, as we entered into this, call site, the await basically meant, hey, this could take a little bit, because this is like an RPC. It's a remote procedure call. It's not a local call. It can take a little bit. So let's await. Let's wait for all this stuff to happen that we just went through between these two blobs here, right? Let's wait for it to package everything up, send it across, get the answer, package that back up, send it back to us, right? And once we have the answer, then we can continue. All right. So we're going to say, hey, I want to wait for this to finish before we get the balance here, or before we proceed with the balance. Or else if we continued, it would still run in the background here, but then, we wouldn't really get the result back when we needed it. Let's say we want to show the balance right after this. Okay, so that's what's happening there. Now, every part of that process, it has a name that we're going to learn. So packaging it up is serialization, as we just said. Sending it across, shipping the bytes is like the wire protocol, and then unpacking on the other side is deserialization, and so on, right? So really, again, anything that takes a function call, sends it across a network, runs it on another machine, returns a result, that's RPC. It's really as general as that, okay? So one thing I just want to mention before we proceed, you can also say, what does procedure mean, right? Remote, we can understand, right? It's remote. It's on another server far away, potentially. It could be 10 feet away. It could be 10,000 miles away. Remote is we understand. Call, we understand as well. We're calling something. So procedure is actually just an older name for function. So back when this term was coined, back when RPC was coined, it was called procedures. We call them functions today. So, if it had been coined today, it would have probably been, function, a remote function call. Okay. So that's the same thing. It was coined in the 70s and early 80s, by the way. But function was not at least a universal word at the time. So that's all that means. So it's just calling a function on a remote machine. That's all it is, right? Now, we mentioned since this definition, right, is so broad, you might ask, so is it only related to Web3 or is it broader? It sounds a lot broader. You'd be right. It is a lot broader. Like, so when your phone, on your phone's weather widget, right, the phone doesn't know the weather forecast locally, right? So the phone needs to talk to the server of the weather app, wherever that is, and then get the result of the weather, and it comes back, right? So when you check out with Stripe, you need to tell Stripe to charge someone, say, $20, right? That lives on their servers. A Google search, you also fanning out many RPC calls, right? A database query in general is an RPC call. REST API is RPC call, and then of course blockchain, obviously, as we have been focusing on here. Every dApp, every wallet, every block explorer, every indexer, analytics dashboard, every single one of them from a software engineering standpoint is an RPC client. So it's very broad. Everything is really an RPC these days because there's so much network and so much internet. Everything is interconnected. Everything is really an RPC call. But we're going to be focusing specifically on blockchain. All right. So almost every interesting thing your software does, every piece of external data it reads, every action it triggers, it's some form of RPC. All right. Now, let's just take a look in this first episode here on the history of RPC. All right. So it's kind of started in the 70s. Okay. That, this sort of concept of, pretty quickly after ARPANET, which was the first internet, obviously that was the whole point of it. People realized, well, we're going to be calling functions on remote computers, and we need some nice framework to do this so we can be done very consistently and easily and with low fault and all these things, right? So that was pretty quickly obviously realized and developed. So started with James White, in his RFC 707 here, worth looking up, reading, but basically he's saying, well, hey, we need to improve network computing in a sense, right? That was 75. Then Bruce Nelson did a PhD and went to work at the Xerox after, but did a PhD, and that's when he coined the term RPC. That was in 81. So he sort of like did like a review basically, and like really dove into all these different ways it could be done. You can imagine doing these remote calls can be done in a ton of different ways. And we'll actually explore the many ways, and that's still true. When he would then after that he went to work at Xerox, and Andrew and him wrote this paper that's literally called Implementing Remote Procedure Calls. All right. Also worth a read. You can sort of see here that, they're basically saying, look, RPC is quite simple, they're saying, right? It's just based on the observation that procedure calls are well-known and well-understood mechanism for transfer control and data within a program running on a single computer. So you're running a program on your single computer, on your local computer, and you now want to transfer control, meaning call a function, somewhere else, right? And that's sort of what they're saying here. So we already know how to do it locally, right? So they're proposing this same mechanism simply be extended to provide for transfer control and data across a communication network. We already know how to do it locally. Why don't we just kind of keep the syntax the same and everything the same, but just under the hood, we kind of just extend that to be able to do it across the network. And that's sort of like what's involved here. And as they're saying here, when you do this remote procedure call, right, when you invoke it, the calling environment is suspended, and that's sort of like that wait part, because you got to wait for the result obviously to come back, right? So we're going to pass the parameters across the network to the environment. That was that line we drew from the client to the server, where the procedure is to be executed, so it'll run on that server, and that's the callee, and the desired procedure is executed there. So the server runs that function. So for example, for blockchain, it asks the blockchain, because that server has access to the blockchain, has the blockchain on it. What is the balance of this wallet? Okay, great, get it. And then the procedure finishes and produces results. The results are passed back to the calling environment. So that's back to that client, where execution resumes as if returning from a single machine call. So they sort of like to call it like a single machine. You're not involved in networking, so you only have single machine versus multi-machine. So that's sort of the idea. And there's a lot more really cool stuff in this paper. But this was in 1984, all right? And then other versions of RPC started to arise. Dave Weiner, Box with XML RPC, around the 2000s, a few years before, but over this time frame. Roy Fielding then develops REST. There was some discussion about whether REST is RPC or not. And then in 2005, JSON-RPC arises, which is a lightweight JSON format instead of XML. All right. So that's sort of JSON-RPC 1.0. Fast forward 5 years, JSON-RPC 2.0 comes around, and 2015, Ethereum mainnet launches, and they launch with what they call the Ethereum JSON-RPC API, and that becomes the standard. All right. And then what happens in 2015, 2016 is, and this will become relevant later, but Google basically open sources gRPC, all right, which is just their optimized version of RPC. Now, fast forward to today, we have all these coexisting RPC methods. We have JSON RPC, we have REST, we have gRPC, and so on. And WebSocket-based RPC is on the rise as well. In Web3, which is what this will focus on this series, JSON RPC definitely dominates. So that's the idea, and that's sort of a little bit of history. But the core problem, right, throughout this history is like, really, how do we make a function call across machines work? That hasn't really changed, right? What has changed is the world around it. So what I mean by that is there is a reason why gRPC was introduced. There's a reason why these other JSON RPC was introduced from the initial version. All that is just governed by the new network speeds, the new data, amounts, and all this kind of stuff. Does that make sense? So like we can kind of say like each era of RPC kind of solved the part of the problem that mattered most of its era. Okay, so our era has its own version of that problem, and that's what we'll get to. All right. So now specifically to blockchain, but as we understand now, it's actually RPC is very, very general, but specifically to blockchain, of course. In our world, Web3, blockchain, dApps, right? RPC is not just one layer among many. you can really say it's the layer, just like we said at the start. Like, it's really how everything talks to everything. So the blockchain itself is fundamentally a giant shared database, right? It's a little strange. It's distributed. It's append only. It has this important property of Byzantine fault tolerance. But at the end of the day, it's a database, right? So to read state, you need to ask a node. And to write state, you submit a transaction through a node. There's really no other interface, if you will. Okay, so every dApp that you ever used, every NFT marketplace, DEX, wallet, block explorer, and so on, from a software engineering standpoint, it's all just an RPC client. Okay, its job is to call functions on a node. That's all it does. Okay, so in this series, we're just going to focus on Ethereum, and just because we feel like every Web3 developer has spent time with some EVM or Ethereum based work. That's the idea. But I want to get it clear that the RPC layer, again, the fundamental layer, determines whether your app feels instant or sluggish. It's really that important. It determines whether your app works at all on a flaky connection, does it even load anything. It determines how much your app costs to operate as well. Very important. Every read is a billable request to some paid provider. It also determines whether your app can scale to 100,000 users without melting. And critically, almost no Web3 developer ever looks at it. That's the sad truth, but we can change that. That's what we're going to do here. So, most developers install a VM pointed at some URL from some big provider, and you never think about it, what's happening on the wire. All right, and that's what leads to a lot of issues, actually. So it's really the layer, I would say, that no one looks at, and it's the layer that decides whether your application is good. So by the end of this series, you'll be the developer in the room who actually understands it, and so that's super important. So now we've been saying that RPC is just a function. It's calling a function on the machine, right? Makes it sound easy. Call the function, get result, done, right? The actual picture is exceedingly much harder. Okay, and here's why. Is it so much harder? Well, the function can fail. Okay, the network can drop, the server's overloaded, the call times out. What does your code do in that case, right? That can actually get pretty tricky. What does it do in all those cases? Latency is physical. Okay, so it takes light about 130 milliseconds to go around the world and back. You can't really do much better than that. So your dApp is going to feel it, because 130 milliseconds is roughly an order of magnitude or two above what like a normal, like a fast web page would load. Bandwidth costs money, right? So every byte costs something, right, that you need to pay for. And on mobile, it costs the user real money. So this innocent call you're making, it could be 8 kilobytes. It's going to cost you. Servers go down, right? Or get DDoSed, or rate limits you. Where does your app go when the RPC endpoint disappears? It would just break, not show anything, not show any balance, right? And when users can't see the balance, you might fall back to zero. Maybe it shows a zero. That's very bad. Looks like they lost all their money. That's not good. Data can, of course, also change, right? A balance now is not a balance 10 seconds ago, right? So can you cache it? For how long can we cache it? There's a lot of caching issues, actually. And then, of course, call cascading, all right? So many dApps, you need to make 5, 10, 50 RPC calls to just load one screen, right? Each one wait, so you make one call, it's going to wait, make another call, it's going to wait, make another call. Let's say you need 50 calls to load a screen, like to get the balances of various tokens or something, right? So what do you do? So every one of these, okay, is an episode, all right? So we can go down here and look at this. So every one of these is an episode, and we're really going to take each of these problems very seriously. We're really going to understand it. We're going to build it. We're going to break it. And we're going to see how the industry has tried to fix it. And so by the time we get to the final episode, every one of these will be solved. And the architecture that solves them is going to look obvious. All right. That's the goal. We're going to look at full disclosure directed dApp, which is a company I co-founded, which the whole point is to do away with all these issues, particularly for blockchain technology, make it a lot easier. We'll get into that. But we're going to understand the foundational issues before we get close to that. Okay. So, really back where we started, right? This line of code right here, it is, you can call it, it's the function call that crosses an ocean, if you will, right? It's not on your local machine. It could cross an ocean, go to another continent, call a machine there from a company you never heard of, get the balance, send it right back to you. It's wild. But now you know what it is. You know that it's RPC. You know it's the same idea that powers Stripe, Google Search, your phone's apps, and every single dApp in existence, right? What you don't know yet, I will assume at least, is how to build it. And so that's going to be the next episode. We're going to open 2 terminal windows. We're going to write about 100 lines of code. And by the end of that, you'll have your own RPC system running. Pretty exciting. I'm super excited for it. And you'll have seen every part of the trick, right, from the inside. So yeah, thanks for being here. It's going to get really, really exciting. It's going to get really, really exciting. We're going to build RPC. We're going to break it. We're going to really understand it. So thank you for being here. Yeah, welcome to this series.